When you have t's involved with y and x, it's a little more difficult. It's called parametrics. Now, instead of having x as your input variable, you have t for both y and x. And y and x are now output variables. Now, to get dy over dx, which means the derivative of y with respect to x, you must divide the derivative of the y function with the derivative of the x function. Now let's see how to do that. Okay, so when you're doing calculus, right, you need to understand that there are some steps that you can take with certain situations. And I'm here to show you those situations. And you can keep these situations in mind when you have to solve a question that you don't know how to solve. Now let's say this is one of those questions, right? So now I want to find dy over dx. So the way I would take the derivative here would be looking at it as dy over dt and dx over dt, because t is our input variable. So that's the only variable we can take the derivative of. But let's say that this dy over dx behaves just like a fraction, because we literally see this as a fraction, right? So I'm going to write dy over dx as dy over dt and divide that by dx over dt. Now when you do that, right, these dt's divide each other out. That way, we actually get dy over dx. It's a basic operation. If it was dx over dy, we could do the same thing. Again, it doesn't need to be x only. It can be any variable in the bottom, like dt here. If y is the input variable, it would be dy in the bottom, and then probably something else on the top. And to achieve all of that, all we have to do is multiply the equations in certain ways that the third variable gets divided out, and we're left with only the two variables we're concerned about. So this necessarily is not multivariable calculus. So since we know how to do this, we can go ahead and start with taking the derivatives of both the functions and then dividing each other. So now y equals 3t plus 4, that's the derivative of that equals 3, right? Same thing with dx over dt, which is 2. dy over dx would be 3 over 2, because I'm dividing dy over dt with dx over dt. So the answer is 3 over 2. Okay, let's say instead of this, I had squares for the t, right? Like that. My new dy over dt would be 3t squared, so 6t, and then dx over dt would be 4t. Now again, we would divide it, and dy over dx would basically be 6 over 4. The t's divide themselves out. Now let's say the t's do not divide themselves out. For example, we had a 3t squared for y and 2t for x. It's still okay to leave the t in there because there's no way to get the t out, and your question will not ask you to take the t out. So that's basically what parametrics are. All you have to do is divide dy over dt over dx over dt, or vice versa, to figure out what you really need in terms of the derivatives. Alright, let's talk about second derivatives. And before we go to the parametric functions, let's understand what second derivatives mean. And to be honest, second derivatives is just the derivative of a derivative. So, in other words, I'm taking the derivative of this equation's derivative, which would be d over dx of 6x plus 4. And the answer to that would just be 6. It's not that hard. And in fact, you can keep on taking the derivatives, and this would just go down to d3y over dx to the third, and then we would just take the derivative of that, of 6, which would be 0. And eventually, when you just have equations like these, eventually all your derivatives are, as you keep on taking the derivatives, it's eventually going to lead to 0, which you can understand from here. But that's something we'll talk about later. But here, you can see that this exponent will change every time you take the derivative. You'll just add by 1. So what about parametrics, right? Parametrics work a different way. For parametrics, everything's based on t. You're taking the derivative with respect to t, not with respect to x. So what do we do? So a normal derivative, or a normal derivative of a derivative, would work like this. Okay? Here you will get d squared y over dx squared. One of these d's won't exist because of the derivative. In the bottom, I mean. On top, the d's get squared. So we have to do the same thing for the parametrics. But once you understand this, you will never have to do this ever again. I'm just doing this to show you how this works. So, d over dt is mandatory. You can't do with x. dy over dx, which we found was 3 over 2 from last time. But when we do this, right, this will end up to be d squared y over dtx. Now we need to get rid of this t and multiply an x here. To do that, there's one very easy way to do it. That is, you divide this whole thing by dx over dt. Now, these dt's divide out and this dx goes here and squares. Now you have a dx squared in the denominator. So, your formula for taking the derivative of a derivative of a parametric is basically d over dt of dy over dx, but divide that by dx over dt. And that's how you do it. And this actually works for everything after d squared y over dx squared. You would just, this is basically the derivative of a derivative in a parametric. So this could go in here in place of dy over dx. And then you would do the same thing for d cubed y over dx cubed. But we're not going to see that because it's basic redundancy. Because we're already doing this for d squared y over dx squared. So, let's see how this works now. So dy over dx is 3 over 2, and I'm going to take the derivative of that with respect to t, which is going to be 0. And I'm going to divide that by dx over dt, which is 2. 0 over 2 is 0, so the answer is basically 0. And there you have it. These questions aren't that bad once you get to know how to do them. The most challenging thing about calculus is understanding what you can do with the notation. That's why I'm showing you these examples, and I'm showing you how I get these different scenarios and these different workarounds to show you how exactly to take the derivatives, right? Now, this way, if you get something challenging, you can apply some of these methods to see if it works or not. Because after all, some of calculus is basic trial and error. That's how you learn.